Hello everyone, this is Rakshitha.R studying in Sri Venkateshwara College of Engineering of EC branch. Today I am presenting my topic on numericals based on Thevenins theorem and superposition theorem. Firstly, Thevenins theorem states that any two-terminal linear and bilateral network or circuit having multiple independent and dependent sources can be represented in a simplified equivalent circuit. This is known as Thevenin's equivalent circuit. Next one, superposition theorem. It states that in any linear active bilateral network having more than one source, the response across any element is the sum of the response obtained from each source considered separately, and all other sources are replaced by their internal resistance. Let us see the first question. The Wheatstone bridge in the circuit shown is balanced when R2 is 1200 ohm if the galvanometer has a resistance of 30 ohm. How much current will be detected by it when the bridge is unbalanced by setting R2 to 1204 ohm? Circuit is given below. It contains four resistors R1, R2, R3 and R4, where R1, R3 is parallel to R2 and R4, and it contains galvanometer with two terminals A and B and voltage source of 120 volt. We should find VOC. We are interested in the galvanometer current, hence it is removed from a circuit is to find VOC, and we get the circuit shown. For finding I1, we voltage divided by R1 plus R3. Voltage is 120 divided by R1 is 900 plus R3 is 600. That is equal to 120 by 1500 ampere, where I2 is equals to 120 by 1204 plus 800. That is equals to 120 by 2004 ampere. Applying KVL clockwise along the path to the galvanometer terminals B minus A, that is 900 ohm, we get 1204 I2 minus V1 minus 900 I1, that is equal to 0, where V1 is equals to 1204 I2 minus 900 I1. 1204 into I2 value is 120 divided by 2004 minus 900 into I1 value 120 divided by 1500. That is equals to 95.8 megavolt. After the simplification, the circuit is as shown below. To find R1, deactivate all the independent sources and look into the terminals A and B to determine the Thevenin's resistance as shown, where R1 is equals to RAH minus 600 parallel to 900 plus 800 into 1204. That is equals to 900 into 600 by 1500 plus 1204 into 800 by 2004. That is equals to 840.64 ohm. Hence, the Thevenin's equivalent circuit consists of the 95.8 megavolt source in a series with 840.64 ohm resistor. If we connect 30 ohm resistor to this equivalent network, we obtain the circuit as shown. I0 is equals to 95.8 into 10 power minus 3 divided by 840.64 plus 30 ohm, that is equals to 110.03 microampere. The next question, this question is based on the superposition theorem. For the network shown in figure, apply superposition theorem and find the current I. In the circuit, it contains resistor, voltage supply. Open the 5 ampere current source and retain the voltage source. The resulting network is as shown. The impedance as seen from the voltage source is Z is equals to 4 minus J2 plus 8 plus J into 10x minus J2 divided by 8 plus J8, that is equals to 6.01 minus 45 degree ohm. I naught is equals to J20 by Z, that is equals to 3.328 into 135 degree ampere. Next, short the voltage source and retain the current source. The resulting network is as shown. Here, I is 5 ampere. Applying KVL for mesh I and mesh 1 and mesh 2, we get 8I1 plus I1 minus 5 divided by 10 plus I1 minus I2 into minus J2, that is equals to 0. I2 minus I1 into minus J2 plus I2 minus 5 into minus J2 plus 4I2, that is equal to 0. By simplifying, we get 8 plus J8 into I1 plus J into 2I2 is equals to J50. And J2 I1 plus 4 minus J4 into I2 is equals to minus J10. By solving, we get I1 is equals to I2 is equal to 8 plus J8 J2 J50 minus J10 divided by 8 plus J8 J2 J2 4 minus J4. It is in the form of matrix, that is equal to 2.897 into minus 23.96 degree ampere. After simplification, the circuit is as shown below. Since IA and IB are following in opposite directions, we get I is equals to IA minus IB is equal to 6.1121 into 144.78 degree ampere. Thank you.